Namaste dosto. Imagine you have a jar full of colorful marbles, each with a slightly different size. You might wonder, how much do these marbles differ from each other? In statistics, one simple way to measure this difference, or spread, is called the range. Today, we are going to explore what range means and how it helps us understand data. So, what exactly is range? In statistics, range measures how spread out the data values are by looking at the difference between the largest value and the smallest value in a dataset. Think of it as checking how far apart the biggest and smallest marbles are in your jar. It's one of the simplest measures of dispersion, meaning it quickly tells us about the variability or spread in the data without complicated calculations. Mathematically, it's really straightforward. Range equals the maximum value minus the minimum value. So, if the biggest marble is size 10 and the smallest is size 4, the range would be 10 minus 4, which is 6. But remember, while the range is easy to calculate, it can be heavily influenced by outliers, those rare extreme values that don't fit the rest of the data. For instance, if there was one huge marble much bigger than the rest, it would inflate the range and might give a misleading idea about typical variation. Imagine this on a number line with 6 data points marked. The maximum and minimum values stand apart, showing the overall spread clearly. That's your range in action. Let's keep this idea in mind as we move forward. Now that we know what range is, let's talk about why we use it and when it might not be enough. Range provides a quick and basic tool to assess how spread out data is, especially when you have small or distinct sets of numbers. For example, when a teacher quickly wants to see how test scores differ in a class, range gives a snapshot without spending too much time. In real life, range is also very useful in quality control. Suppose a factory is making batches of screws. Range helps identify if one batch has screws that vary too much in size compared to others. This fast check can flag big variations immediately. However, relying only on range can sometimes be tricky. It doesn't tell you anything about how data values are spread between the minimum and maximum. Two datasets can have the same range but look very different inside. For example, imagine two box plots side by side. Both could have the same range, but one's data might be tightly packed in the middle and the other spread out unevenly. Range won't distinguish between these. So, while range is handy, it's important to use it alongside other measures when precision matters. Keep these pros and cons of range in mind as we practice calculating it. Let's get our hands dirty with some calculations. To calculate range, first identify the largest value in your data and then find the smallest value. After that, just subtract the minimum from the maximum. That's your range. Here is an example. Suppose your data points are 12, 7, 14, 22, and 9. To make things easier, arrange these in order: 7, 9, 12, 14, 22. Now, the minimum is 7 and the maximum is 22. Applying the formula slowly, range equals maximum value minus minimum value. So, range equals 22 minus 7, which is 15. This tells us that all data values lie within a spread of 15 units. Imagine these numbers on a number line with points marked and the max and min highlighted. You can visually see how the data stretches between those limits. Ready to try applying range in a new example? Let's go ahead. Here's a solved example to make range even clearer. Suppose we have marks scored by students in a test. The mark values are 2, 5, 7, 10, and 13. Remember, the frequencies or how many students got these marks don't affect the range calculation. Only the scores themselves matter here. Step 1. Identify the maximum and minimum marks. The maximum is 13 and the minimum is 2. Step 2. Apply the range formula. Range equals maximum minus minimum. So 13 minus 2 equals 11. That means the scores have a spread of 11 marks. The students' marks lie within this interval. Picture the marks in a table with the marks column highlighted and imagine an arrow stretching across a number line from 2 to 13 showing the range. Wasn't that straightforward? Let's explore one important limitation of using range now. Range can sometimes trick us because it is very sensitive to outliers or those unusual extreme values. Look at these two datasets. Data is 10, 11, 12, 13, 14. Data B is 10, 11, 12, 13, 98. For data A, the range is easy. 14 minus 10 equals 4. A small spread, so values are quite close. Now, data B has the same group except one number shoots way up to 98. The range here is 98 minus 10, which equals 88. Though most data points are very similar in both sets, this single outlier in data B makes the range leap drastically. Imagine two scatter plots side by side. Data A's points close together, data B's with 1 point far out. This shows why range might give a false impression of spread when outliers exist. So, be careful and always consider the context when interpreting range. One final recap to seal today's learning. Let's quickly summarize the key points. The formula for range is range equals maximum value minus minimum value. This formula works for both raw data and group data. When dealing with group data, remember to consider class boundaries instead of just values. Also, the range has the same unit as the data values themselves. If your data is in marks, your range is in marks. If it's in centimeters, the range is in centimeters. Range is quick to compute and gives a basic sense of how spread out data is. But watch out. It's highly affected by outliers or extreme values, which can make range misleading. Since it doesn't show the distribution of data inside the range is not suitable alone for detailed statistical analysis. To get a fuller picture, use range alongside other measures like variance or the interquartile range, especially when preparing for exams or real-life data interpretation. Arey wah! You've done a fantastic job understanding range today. Keep practicing, and soon you'll handle all kinds of data with confidence. Remember, every big concept starts with a small step. And this was yours for Statistics Dispersion. Shabash, keep up the good work.